I'm with you, sir. I'm with you.
Someone said he or she cannot see the screen. You can log out and log in. Okay. This one, right?
Yes. Double bond in front of. Okay.
The second one, right?
No, the third one, the last one, double bond. And then CC again.
Hello?
Hello, sir. Are you hearing me?
I can hear you. I can hear you.
Okay. That after the last C, it has a double bond.
Okay.
After that, you have another CC.
After this, Abi,
After the last, yes, after the last carbon, we have double bond.
we have double
Yes,
bond, right?
yes. And after that, CC.
Yes.
C.
See what?
And C again.
I'm coming. Let me loud this thing. I just increase the volume. Okay, after this, another again, right?
Yes.
C.
Yes. I can't see your screen again.
You can't see my screen.
Yes.
I think it is a problem of network.
Okay.
I think it is a problem of network. I don't know. You can see it now.
Yes, sir.
Okay. What else again?
I'm coming. It has for the, if you start from the left hand, hydrogen.
Okay, you can. Yeah. Hello.
Hello, sir. From the,
What
we
you
start
can?
from the left, it has hydrogen. Hello, sir. Can you hear me?
I can hear you, please.
Okay. Yes, hydrogen is the yes. And then it has CH3 at the top. CH3 at the top. The second one has CH3 at the top and CH3 at the bottom. Yes. That's why the third one has first one has chlorine. Chloro.
Okay, let's listen to what Amida Dosumu said. She said, hello, brother. That's what I want to say before. Amida said, you should help us to snap it and send it to the group, please. So that it will be easy for it's easier for us, please.
Okay, sir. I will do it right now. But the group is not yet open for us.
It's not yet open for you.
It's only for the admin.
Okay,
that
why you
that
please that? Yes, okay, fine. I'm the one that posted last on the group now. So
okay, sir.
You can click and send it to me and forward it to the group so that people can have access to it, right? Is that okay?
Okay, sir. I'll do that.
Okay, sir.
Send, sir. I'll send it.
Okay.
You sent it to me.
Yes.
Okay, we could access it like that, right?
Yes,
Can
sir.
we? Okay, let me just check this. Okay, we could see this. This is the what's it called? This is what my brother said now. And we have CH3, CH3, CH3. And the next thing is that we have Cl, Cl. We have on top here, we have Cl, we also have Cl, and we have this. We also have this as well. Is that not so?
Yes, sir.
Are we okay with that? We don't need to check the option, so we just need to name it. Okay. Can someone tell me where I start counting based on the rules that guide the naming of alkene? This is alkene, right?
On the left side.
From the is it from the here, right?
Yes.
Yes.
From here, we are start counting.
Yes.
We are going to start counting here from here.
Yes.
Are you sure?
Yes, sir.
No.
No. Okay. Where we start counting?
I think from the right.
You think from the right, or you are not sure. Why is it from the left? Why is it from the right? So someone should tell us.
From the left because of the double bond.
This is the right, oh, not the left. When you are looking at the board, so this is your right, or this is
Right,
your
right.
left.
Okay. From
We are
the
starting
right.
from the right. Why? Because of the what? Because the double bond
Double
is
bond.
near this C. Are we okay with that? And we said
Yes.
Yes.
the first thing, what's the first rule in naming of organic compound?
Mm.
You must not know the long chain.
The longest chain, Abi, the principal chain, Abi. Now let's count. If you start counting from here, 1, 2, 3, 4, 5, right?
Yes.
This is the branch. 1, 2, 3, 4, 5. This is another branch, right?
Yes.
Yes, sir.
1, 2, 3, 4, 5, 6. Is that okay? We have 1, 2, 3, 4, 5. 1. We have the 5 as the longest chain here, branch here, downward. Branch here, upward. 5 as well. 1, 2, 3, 4, 5, 6. You know, it is a chain. This is a chain. Is that also? And we
Yes,
are
sir.
counting carbon to carbon. 1, 2, 3, 4, 5, 6. That is the longest chain here is what? Is 6.
6.
Are we together?
Yes.
Are we together? 6. We are counting 1, 2, 3, 4, 5, 6.
6.
After we've counted this, right? This is the
Yes.
substituent, right? This is another substituent without counting. This is another substituent, right? This is another substituent. Are we together?
Yes, sir.
Yes, sir.
So fine. So how do you now go about it? We know that we have halogen, halo group, and we have alkyl group as the substituent, right?
Yes, sir.
And then also, now for the allo group, we have chlorine at number 2, we have chlorine at number 3, we have methyl at both number 4. Are we together? Hello?
Yes,
Now,
sir.
so now, in chemistry, you won't be taught this. We have what we call inductive effect. What I call it? Inductive effect. This inductive effect gave us how substituent, how they are, how powerful they are to each other. Chlorine normally is powerful than CH3. Are we together? Fluorine normally is powerful than chlorine. The one that is most powerful will be the one that will come first. Are we together? If actually we want to follow, yes. Now in this case, chlorine is what? Is more than what? Is highly effective than what? Than alkyl group. So chlorine is at number 2 and number 3. We can say we have what? 2, 3. How many chlorine like that? 2.
Die.
It is what? Dichloro. We have methyl at number 4. 4, 4, dimethyl. Are we together?
Yes, sir.
Yes,
We
sir.
have carbon. The longest chain is 6. And 6 what?
Hexane.
Hexane. But don't forget the position of the double bond. The position of this double bond is on carbon number what?
2.
Carbon number 2. It will now be what? X2
2.
in. Are we together? 2, 3, dichloro, 4, 4, dimethyl, X2 in. Are we together? Are we together?
Yes, sir.
My brother, you get it?
No. Yes, sir.
Fine.
Sir.
Is the option there? Do we have the option there?
Yes. That is C.
Option C. We have the what? 2, 3, dichloro, 4, 4, dimethyl, X2 in. That's option C.
Thank you, sir.
Please, do we get it right? Do you all get it? Yes, fine. So that's good. We move.
So I also have a question.
Oh, yeah, what's your question? You want to send it?
Yes, sir.
Okay. When you are done with your sending, just let me know. Let's be fast with it.
I'll send
So
it,
that
sir.
you sent it. Okay, that's fine.
Yes, sir.
How could I see this now? You bent it. Okay, you sent another one, right? Which one? Which number? Let me see if I can save it here. Yeah. Sorry, please. Oh, I was not meant to do such a thing. Okay. What question? Number what?
44, number 44, and number
40.
43. Mm.
This is 43. 43 is what is the IUPAC?
Yes, sir.
What is the IUPAC name for hydrocarbon? Okay, let us just write it. You see, I've written this.
No.
Let's quickly write this, please. Okay, are we done with it, please? Let's be fast. Or you can screenshot it so that you will be so that we can go. Because we are in Ramadan, most of us will have another thing to do.
Okay, sir.
When did you guys finish the first class?
After 4.
What time are we praying?
4:15.
Where?
We finished early because our network was bad.
Okay, you guys will finish early. Maybe I'm going to discuss with the so that we'll be able to attend if you want to attend tafsir or any other thing, and we have
Yes.
another package for you guys. Is that okay?
Yes.
Okay, that's fine. Are we done?
Yes, sir.
Okay. This is the question. We have CH3C. We have CH3. We have C. We have double bond. We have C. We have C again. We have CH3. We have CH3. We have CH. We have CH3. Is that all? Is that the question? C, CH2, okay, don't want CH. I think correct with that. I think this is the actual question. Have I sent it to the group? No.
No, you haven't.
Person. Okay, I think I've sent it. Sorry for the person. Okay, fine. I think this is the question that we posted on the group. So we can quickly check it. Is it correct? Let's quickly check it, please. Oh yeah, let's compare, please.
It's correct.
Correct, right?
Yes, sir.
Others. Okay, that's fine.
It's correct.
Now, what's the first thing? Are we together?
Yes,
Hey,
sir.
Yes, sir. Yes, sir.
hey, what are we doing in this country with the network? I don't even know. The first thing is to check the longest chain, right?
Yes.
You can tell
Yes.
me the longest chain here. Count it by yourself and tell me the count it.
Six.
6.
6,
Yes.
6,
5.
5.
5. Someone said it is 5. Who else? Who have any other opinion? I want us to talk. Adaya Blast. That's fine.
6.
Okay. 6. Who said 5?
6.
Let me 6. You later agree that it is 6 now. Are we counting straight or branch?
Branch.
Branch. Now, where are we start counting? Is it from right to the left, left to right? Where we start counting, please? Let's talk, please. Where are we start counting?
From the left.
On the left. Okay. From here, right? This is how we count, right?
Yes.
Yes.
We count here 1, 2, 3, 4, 5, 6. If we count from here to here, so the double bond is still on carbon number 3, right? If we count
Yes.
from the right as well, the double bond is still on carbon number 3. Is that also?
Yes, sir.
Yes, sir.
Now, assuming we now start counting from the left, this will remain the substituent, right? This will also remain as substituent. Is that also? So definitely we have 3 methyl at carbon number 3 and methyl at carbon number 5. It will now be what? 3, 5, dimethyl, right? What do we have? X, Abby? X what?
3.
X.
X3 in, right?
Yes.
And we start counting from the right side. And we count like this. 1, 2, 3, 4, 5, 6. That shows that the bond is still at carbon number 3. Is that not so?
Yes.
In this case, we still have these 2 substituents. It will now be what? 2, 4, right?
Yes.
Dimethyl what? X
S
3
S
in.
3 in.
Which one are we now picking?
2 for diamond, 2 S 3 in.
2, 4. So we need to watch it very well before we start naming. You need to check if you name, you count from the left to right or from right to left. If they give you the same thing, you now check which name is the real name. But if the bond location is not the same with that of the what? With that of the counting from right to left or from left to right, you now pick the one that is what? That is near. But both of them meet at the same point at carbon number what? Carbon number 3. Is that okay? That's why we go for the smallest number. Do we have that in the so-called option? Do you have that answer in the option? We have
Yes.
2. Yes. Option what?
C.
Option C. Listen, we have 3, 5. That's where the problem now lies. We have 3, 5 dimethyl X3 in, and we also have 2, 4 dimethyl X3 in. Which one is now the correct name? And we got both of them here. Which one is now the correct name?
C.
2,
C.
4 dimethyl. Okay.
Why is it 2, 4? Why is it not 3, 5?
Because the 2, 4 is the smallest number.
The smallest number. Because when you add 2 and 4 together, gives you 6. And when you add 3 to 5 together, gives you 8. And we said the smallest number is what? Is the real name. So if someone is not careful of it, you surely pick what? 3, 5. Are we together? So and 3,5 is not the what? Is not the real name. So the real name is what? C, which is 2,4
For
dimethyl
dimethyl
X3.
So they
X3.
chose 3,5-dimethylhexane
So
as
that
the
shows
as
that
3 in here.
so that shows that the jam series is wrong. They are not correct in that aspect. So it is not all the answer they choose. They are man like us. They are human being like us. It's not all the answer they choose is the real answer. Are we together? So that's why you need to understand what you are doing perfectly. I don't think we are right. We get it right. Are we okay with that?
Yes.
Yes, exactly. So that's actually what we are saying in that sense. Can we proceed?
Yes, sir, we can proceed.
Or we want to write? Or we want to write it? Okay, let's put it down. Oh yeah. So my sister, do you get it? Did you get it right now? That's fine.
Look at it.
Are we done with it?
Yes, sir.
Others, can we
Another
proceed?
question.
What's
Sir, I want to ask a
what's the
question.
question?
Sir, how are we going to
Okay.
know if we have to count in a straight chain or in a branch chain?
Yes, that's why I gave you the method that we use to name. Do you understand? It's not that we are counting straight or branch. We are counting the longest chain, carbon to carbon. If you count in a straight chain like this, 1, 2, 3, 4, 5, you see that the longest chain here is 5, where you count straight. But if we still count branch, we will see that it is more than 5. We are actually counting the longest chain, not that we're actually counting the branch chain. Did you get it now? So even if it is longest chain, that is what? If it is the straight chain that is long, definitely we are going to use the longest chain. We are going to use the straight chain. Are you getting it right? So, but in this case,
Yes, sir.
the branch chain is the one that has the longest. Do you all get it? My sister, you get it right?
Yes, sir. Yes, sir.
That's
Yes,
fine.
sir.
So definitely everything is okay in that sense. Can we proceed?
Yes, sir.
So she also mentioned something like this, that when we have something like this, CH3C, and we have triple bond, could you give us, review the option that we have there? We couldn't see this option perfectly. To choose is something that is very simple. So I just want to
Can I
demonstrate.
snap
You are
it?
going to snap it, the second question, and reveal all the options for us so that we can see it perfectly, so that people can
Okay,
also
sir.
understand what you're saying.
So I've sent it.
We can actually check the group. I've sent it. So this is actually the question 44 that she sent. So now, so this is alkyne. So that's the presence of what? The presence of the triple bond. That's why we call it alkyne, right? Are we okay with that? Hello? Yes, fine. So in this case, when we have alkyne like this, it is part of, I think we need to read the chemical properties, the physical properties, the chemical properties of those compounds. The alkene, alkyne, and the alkene, alkyne, and alkene. We need to check the chemical properties. Part of the chemical properties that we have for alkyne is that alkyne can be reduced. We can write it down that alkyne can be reduced to give alkanes. Alkyne can be reduced to give alkane with sodium dissolved in ammonia. With sodium dissolved in what? In ammonia. Do we hear what I said now?
No.
No,
I
sir.
said alkynes can be reduced to give alkene. Alkynes can be, it undergo reduction reaction. See, what undergo reduction reaction is alkyne undergo reduction reaction. Do you understand now? So, and also undergone the so-called additional reaction. Are we together? So we need to go and read it. So maybe I'm going to review those characteristics for you. But just note this. Note that alkynes can be reduced to alkene with sodium dissolved in ammonia. You will see that the catalyst that we have here, can we see it perfectly? This is what I'm saying. So we have the sodium and ammonia. So, and they said part of the characteristics is that alkynes can what? Can be reduced to what? To alkene with sodium dissolved in what? In ammonia. So let me just give you the reaction. So I said alkyne can what? Can be reduced to alkenes with sodium dissolved in what? In ammonia. So when we have sodium dissolved, this is the, let me just give you this as an example. When we have such things like this, and we have, you know what I mean by R? Do we know R? What's the R? What's the presence of R here? When we have R, what does it mean? Let's talk now.
I think it's
It is what?
alkyl. Abi. Is it alkyl?
Alkyl group. Thank you very much. Alkyl group. So alkyl group. Thank you very much. So that's alkyl group. So when we have something like this, when you see, if you count the numbers of bonds surrounding this, it is 4. This as well, it is what? It is 4. So when we have this, the alkyne with sodium and sodium dissolved in what? In ammonia. This is how it should be. Or you place it beside each other because they are catalysts in this case. So, you know, I said inductive effect before, earlier. Is that not so?
Yes, sir.
I said something like inductive effect. So let me now explain the inductive effect perfectly for you. Inductive effect. So in inductive effect, we have 2 types. We have the positive inductive effect and what? And negative inductive effect. What is this inductive effect? Inductive effect is the ability of carbon, the carbon atoms, to withdraw electron towards itself. To withdraw what? Or you can say to draw electron towards what? Towards itself. That is what we mean by inductive effect. Something want to draw electron towards what? Towards itself. So over electron, right? So that's what we call what? Inductive effect. This is those electron. So you, and this, in this case, alkyne, we withdrawn electron. That is going to withdraw it from the what? From the catalyst side towards what? Towards itself. Are we together? In this case, this is sodium. Sodium will goes to one, and the other will goes to another one. Are we together? And we said alkyne can be reduced to what? Alkenes. With what? With sodium dissolved in what? In ammonia. This is not there. So we just explained that this R here serve as what? As alkyl group. Are we together? So what will it give us? It's going to give us trans. Do we know trans? We've not done isomerism. Have we done isomerism before? We should have done that before.
No.
Yes, we've done it. We knew it before now. Hello, sir. We should know it before because I
Yes,
said
sir.
we have 2 types of isomerism. We have number 1, we have stereoisomerism. Stereoisomerism and structural isomerism. Stereoisomerism and we have structural isomerism. Under stereoisomerism, that's where we have optical isomerism, and what?
Amazing. Yeah. What is it? Eh,
Hey, subhanallah. What do we have for stereoisomerism?
Optical. Mhm.
Eh,
Optical and what, sir?
you asking me? Why are you asking me? We have two types of isomerism from the beginning. So I won't tell you, not everything I'll be telling you. So we have, from the beginning, we have the structural isomerism and we have the stereoisomerism. And I think I've explained structural isomerism, that we have the chain cycle isomerism, we have the straight chain isomerism, we have straight chain isomerism, we have metamerism,
Yes, sir.
we have chain cycle isomerism, functional group isomerism. That's under what's it called? Under structural isomerism. Structural isomerism. So the second one, we have stereoisomerism. And the stereoisomerism is grouped into two. We have the optical isomerism and what? Okay, it's an assignment for
And
you.
the
So
and the
now,
geometrical isomerism.
geometric, thank you, geometric isomerism.
Thank you.
You're welcome.
You go and check it. You go and check it, right? I don't want to be telling you everything. You want to do your jam, so you should know everything. You should know more than I expect. So we have optical isomerism and geometric isomerism. So,
Okay.
but the one that we want to use here is the optical isomerism. So in optical isomerism, when they said optical isomerism means when a carbon is surrounded by four different functional groups. What do I call it? When carbon
When
is
a
surrounded by
carbon-
what? Four
All different
functional groups.
functional
That's
group.
what. So that's when we have. Yes, that's when we have optical isomerism. That carbon. Let me just write it. So, thank you very much for bringing up this question. I think we've written these inductive effect.
Yes, sir.
Yes, sir.
Yeah, I think we've written it. So I want to clean it. That's why I said I think we've written it. So fine. So now, in this case, when we say optical isomerism, I said it is when a carbon is surrounded by what? By four different what? Functional group. Is that not so?
Yes, sir.
That's what I said. So we have OH, we have H, we have COOH. Okay, let me just bring it this way. COOH, and we have CH3. That's what we have. So in this case, this is the carbon. This carbon is surrounded by four different what? Functional group. This is one functional group. This is another one, another one, another one. Are they the same?
No.
No.
Same. No. So that's why we have the optical isomerism. This carbon itself, we call it chiral center carbon. What do I call it? Chiral
Chiral
center.
center
Hierarchical
carbon.
carbon.
So we call it chiral. When they ask you chiral center carbon, just tell them that chiral center carbon is the carbon that is being surrounded by four different what? Functional group.
Group.
Are we together? Why do we call it
Yes, sir.
optical? The word optical, it means it is being exposed to a plane mirror. It is what? It is exposed to what? To a plane mirror. Is that also?
Okay.
That's what, when you add optics, it means with mirror, right? Now, Why we call it chiral center carbon is that because it can move to other direction. It can move to what? To other direction. It means that when you expose this to a plane mirror, when you expose it to what? To a plane mirror, it turns to another thing else. You know, when you are looking at this plane mirror, your right side will be quietly different from what? Your normal right side is the left side. Not so. That's why
Yes, sir.
anything that we have. So in this case, this H up can change to HO. Are we getting it?
Yes,
This
sir.
H still be the same. H3 can be H3C. Are we together? Why this can be HOOC? That's why they call it what? Chiral center carbon. Because on exposure to what? On what? On putting it in a plane mirror. When you put plane mirror to it, turns. It's what? It turns. That's why we call it what? Chiral center carbon. This is what we call optical isomerism. What do I call it? Optical isomerism. So is when yes, it's surrounded by 4 different what? Functional groups. Are we together?
Yes, sir.
Yes, I think we get it right. So we can put it down before I proceed. Oh yeah, let's put it down. So there's something I want to explain in that aspect before Shazai. I think we can proceed. We have limited time. So
Yes, sir.
we are done, right?
Yes, sir.
So now, as Sister Aisha said about the geometric isomerism, under geometric isomerism, that's when we have trans and cis. What do I call it? Trans and cis. Yes, trans and cis. Trans isomerism and cis isomerism under geometric isomerism. Are we getting it? So I think we are getting it right. So we are moving there. So I'm using this opportunity to explain to you the isomerism, optical isomerism, and geometric isomerism. So in this case, we have trans and cis on geometric isomerism. What do we mean trans and cis? It only occurs for alkene family. It only occurs for what? Alkene family. Yes, alkene family. It is only for alkene family, not for any other thing else. How do we go about it? When you have something like this, you now have CH3, you have CH3, H. Don't forget that when I did inductive effect for you, I told you that in inductive effect, there is how we ranked value. We ranked compound. You know, I said chlorine is greater than alkyl group. Is that also?
Yes, sir.
Yes, sir.
Now, in this case, on this carbon, we have 2 things on top. We have hydrogen and CH3. Are we together? On
Yes,
this
sir.
carbon itself, we have CH3 and we have H.
Hydrogen.
Are we together?
Yes,
On
sir.
this side, so we need to divide this into 2 to take this part and this part. On this part, we have CH3 and H on this carbon. Which one is greater between CH3 and H? In inductive effect, CH3 is greater than what? Hydrogen. Are we together? We just go to this aside as well. CH3 is greater than what? Is greater than hydrogen. This side. In this case, we choose CH3 over hydrogen. Here, we also choose CH3 over what? Hydrogen. So CH3 is here, up. CH3 here is up. You will now check whether they are on the same lane or they are not on the same lane. Are they on the same lane? Yes.
Yes,
Up
sir.
and up. Are we together? In this case, we said this is cis isomerism. What do I call it? Cis isomerism. Because both of them are on the same what? on the same lane. Are we together? So let me just give you the trans directly straight.
Hmm.
Sorry, I
This
know you are
is
powerful.
218.
I did not say you should name it, but that's good when why you name it. When we have CH3, we have CH3 here, we have CH3 here, we have CH3, we have H. So in this case, we give this priority, right? We also give this
Yes, sir.
priority. Are they on the same lane? No, they are
No.
on
No.
different lanes. That shows that they are trans to each other. They are what? Trans to each other.
Wow.
So this is trans isomerism. Are we together?
Yes, sir.
So as we are moving on, what's the name of this compound? If you name it, I'm going to give you something. Don't let me promise. I don't have something to give you. What's the name?
Trans 218. The second one.
Trans 2. The second one, yes. Trans what?
Trans
You not
218.
get it.
Ah.
No. Not get it.
Mate, 8. Is it not 2?
You know, you can't. What's the first thing if you want to count? You count the longest chain, right?
Yes.
Yes.
What's the longest chain? This one, you can start it up from the right. This one is 1, 2, 3, 4. Now, is that also?
Yes.
This is butane now.
Okay. 4.
They just slant it for you. They slanted it for you. That's why you are making a mistake. Are we together?
Yes, sir.
Eh? Do you all get it?
Yes, sir.
Okay,
Trans
fine.
2.
So don't worry. I will explain it more for you after we are done with the what we are doing. So now, what they now told us that in this case, okay, do we need to write it down?
Yes.
Yes,
Yeah,
sir.
Okay, let's
everything.
quickly write. We've written it. That's fine. So it is something that is very okay, and with the question we gain a lot. So from that, so it leads to more explanation. So in this case now, we said alkyne. When alkyne reduced to what? It reduced to what?
Okay.
Allicin
Oh,
with
uh-huh.
sodium dissolved
With what?
ammonia.
The sodium dissolved in ammonia.
Sodium dissolved
In
In
ammonia.
ammonia.
in ammonia. So definitely it's going to reduce. And when it reduces to alkene, it's going to give us trans alkene. What will it give us? Trans what? Alkene.
Okay.
So alkene. So we are going to have C double bond. C. Don't forget that we have R before. We have R. This is our R. We also have R before. Here. Are we together? Sodium is coming in. And ammonia. Sodium. And this is what? Ammonia. Are we together?
Yes, sir.
Are we together? Do we have this in our option? I don't know if we have it all. Where is this thing safe? This is not what you're saying. What's the second one you're saying?
That's it, sir.
This is the second one you sent, right?
Yes, sir. Yes, sir.
So we have, okay, here we have CH3. So CH3 in this case is our, what is CH3 in this case? CH3 here is R. Is that also? So definitely we have CH3 here. We have CH3 here. Are we together?
Yes, sir.
So which one is not the correct one? So we have NH2 here. It should be NH3. But fine, you write NH2. So it is fine. We have CH. We have CH, right? CCH. So sodium is here, CH3 is here, which is the alkyl group. So NH2 also moves to it. But is this the answer or this? Which one is that? You know that this one cannot be the answer. D and C, they are not the answer because we said it's reduced to what? Alkane, right? Which one is now the answer? Is it the A or B? I think I don't know what they want to write here.
This NH3.
So whichever, if it is NH3. So if it is NH3, and don't forget that I said they will be trans to each other, right?
Yes.
Yes. If they are going to be trans with each other, it means that I don't know if perhaps they want to bring this NH2 to this side. I don't know which of it. I don't know. But I know that if we are to check, this is under, so we pick A as the option. Are we
They're
together?
both trans.
We don't know whether they are both trans. We don't know, but they should give us in trans.
Okay.
I don't know. You know, they did not write it perfectly to see whether both of them, you know, they did not give us the mark for both of them.
Yes.
That's why. But A should be the options. So far, this sodium is under this carbon, but here, I don't know. We don't know whether it is under this or under this. We shall pick one of these. I think, are we together with that? Are we okay with that?
Yes, sir.
That's fine. So, another question. Do you have any question?
No,
No,
sir.
sir.
I think there is
No, sir.
yes, there is no question in that regard. So, I think let's stop it here. Let's call it a day. Thank you very much for the question you brought here. So, we really appreciate you. How is fasting? Hope it's going smoothly. Thank you
No
very
easy,
much.
sir.
It's not easy. Yes, it's not easy for both for all of us. May Allah make it easy for us. So we are struggling. So me that have been shouting since morning. So it's not easy. Okay, that's
I regret it, sir.
thank you. Yeah, thank you very much. All right, let
Jazakumullah
us take care.
Jazakumullah
Jazakallah
khairan.
Thank you very much. We really appreciate you. All right, bye. Have a nice day.
And you too, sir.
Yeah.
Yes,